This Indian solar station generates heat for factory which manufactures cookware, and its production technology requires degreasing of manufactured cookware inside a bath with a temperature of 680 degrees Celsius. Obviously, the baths gradually lose their heat, and this solar station compensates for the heat losses. If the solar station cannot give the necessary amount of heat on cloudy days, then the workers start a conventional boiler based on liquid fuel, and the boiler covers the heat deficit and guarantees the water temperature of the baths in the range from 55 to 680 degrees Celsius. This is a list of the main equipment of that solar station, and an expert can say that the construction cost of such a station in Europe or the United States is about $200,000, but this is India, and therefore I estimate its construction cost in $100,000, and I predict that this station produces this amount of heat per year. This video will tell you how to additionally reduce the construction cost 7 times, and my solar station project will produce the same amount of heat, but its construction cost will be only $15,000. Firstly, we need to use these solar heaters which were described by another my video about a month ago, and its link is below. This is a list of materials of our solar heater, and we see that it is cheaper than $10 per square meter, but accounting of salaries of Indian workers increases the total construction cost to almost $11 per square meter. Unfortunately, our square meter will produce several times less heat with a temperature of 70 degrees Celsius, and this phenomenon is explained by the difference in the energy parameters of our solar heater and expensive solar collectors. That is why we need to use more than 1,000 square meters of our heaters instead of almost 400 square meters of expensive solar collectors. The second cause of reducing our construction cost is our use of this type of heat storage, but with a thermal insulation thickness of 5 or 10 centimeters, and link to the video describing this storage is below. Our solar heaters will heat the water of the storage during sunny hours, and the temperature of the water will fluctuate between 60 and 75 degrees Celsius. In addition, we must install plate heat exchangers between our heat storage and those baths, and the heat exchangers will transfer heat from our dirty water to clean water of the baths. This is list of expenses for our solar station, and we see that our idea has reduced its construction cost almost 7 times. This is our annual heat production, and we can see that it is equal to the heat production of that expensive solar station with a construction cost of about $100,000. This is my calculation of the cost of heat of our cheap solar station, and it turns out that our solar heat is 3 times cheaper than heat from natural gas and 6 times cheaper than heat from the liquid fuel which is used by that Indian factory. We see that I took into account the expense of Indian capital, replacements of the black polymer film of our heater, other maintenance, losses due to hail. So, we know about a large number of different types of solar heaters which can produce very cheap solar heat, and my YouTube channel gradually finds them, tests and describe. This solar heater is not the best, but it meets the conditions of that Indian factory, and the conditions are the following. First, these solar heaters are ideal for installation on horizontal roofs because they do not require damage to the roof waterproofing for their fixation against a strong wind. However, for example, the location of our solar station on the ground permits the use of more interesting types of solar heaters. Secondly, we see that the Indian factory has no deficit of area of its roof. Otherwise, we need to use a more efficient type of solar heater which will require several times less space for its location. Third, the heating temperature is not high, and I remind you that the high temperature is the cause of the appearance of such bubbles, and the need for their periodic removal increases our operating costs. In addition, the high temperature will reduce the lifespan of this black film, and the higher the temperature, the lower the efficiency of our solar heater. Fourth, we see that our heater can only have a horizontal disposition, and therefore it works well near the equator. However, the location of our solar station in Europe or the United States may require an inclined disposition of solar heaters if we want to have the heat production in winter when the sun is low above the horizon. Fifthly, It is obvious that a large hail will destroy our glass sheets, and therefore we will have additional expenses for installing new glass sheets. That is why our type of solar heater can be uninteresting for some European regions with a high probability of hail. Sixthly, unfortunately, this type of solar heater has labor-intensive maintenance, and this is not a problem for countries with cheap labor, but location of our solar station in Europe or the United States may require the use of some other type of heaters with a small amount of time for their maintenance.